Well, good evening, everyone, from the Death Valley region of California on this gorgeous warm evening here. My name is Mike Jerry, and I'm going to continue our tour of galaxy season and the rich galaxy field that exists this time of the year in the late spring and early summer when the constellations of Ursa Major, or the Big Dipper, and Leo and Virgo rise high into the sky, and between them there is a very rich field of galaxies that we can peruse. And so started on them last night, and we'll continue with more this evening. So let me turn off that little test pattern screen there, and I guess first what I should do before I do any of that, though, is I should always go through this process and show you the setup that I am using, which is a 6-inch imaging Newtonian telescope here. So it's a 6-inch reflecting Newtonian telescope on a Celestron AltAz mount that controls it and points it to the various areas of the sky where there are cool things to see, and then it does the work to track the sky as it rotates around us. Technically us rotating around it, but that's neither here nor there. And it is the whole thing rides on this wedge here that is on my cinder block pier, and this wedge keeps the mount pointed directly at Polaris. So Polaris, the North Star, actually the northern celestial pole, which is just slightly off Polaris. This keeps it all pointed in that direction, so that when the mount is rotating the telescope, it tracks the angular rotation of the sky very, very accurately, so that we can take longer exposures to see more faint stuff. So that is my setup there. Let me just minimize that out of the way, and then so let's go to the Planetarium, which I use Stellarium as my Planetarium software. And last night we did a number of these here, and in fact I should go back and look. We logged which ones we did last night. So these are the ones we started off with, and so we're going to highlight those so that they show up as blue circles, and these are the ones we did last night, so that we don't redo ones we've already done. So let's take off right from where we left off, and let's see what we got here. Mag 12, and pretty small, nothing spectacular there. And this one's actually pretty interesting. Let's do 3726. This one looks like it might be somewhat interesting to do. Let's see. Let me turn my script on so that I can hopefully see the object in the view here. And there it is right there. So a nice fuzzy spot right in there. So let's just start the imaging right away on that. And see what we get. Because it should be right there in the middle. And while that is, what I'm doing tonight is I'm taking 60-second exposures, and which really is very helpful in these nice dark skies, and to see very faint objects. I used to do much shorter exposures, and while you can see stuff, you can't see quite as much as a 60-second exposure will bring in. So recently I've started, since I got my wedge and have polar aligned my scope, I've started doing 60-second exposures, and it really does make a heck of a difference. So first image. Oh yeah, look at that. That's not a bad one. That's pretty darn good. Okay, that's going to be pretty close. Let's give that a few cycles to come in here. With the software that I'm using, which is called SharpCap, what it does is it takes my 60-second exposures and it stacks them. So what that means is it takes the first 60-second exposure and puts it down, and then takes the second 60-second exposure and matches up, rotates or aligns the second exposure, the second image, with the first one using the background stars, and then lays it on top. And you'll see right here in just a second where the background will darken. Boom, right there. The background just darkened a little bit. And it aligns the stars and then stacks the second one on top of the first one. And when it does that, it knows that a pixel that was dark in both of them should be made even darker because it's clearly a dark pixel, and a pixel that was bright white should be made brighter because obviously it was intended to be brighter. If a pixel is different in one to the other, then it averages them out. And if an object like a satellite flashes through the screen, flashes through the field of view, then over time what it will do, because that satellite trail will only show up in one of the sub-exposures and not all the others, as it continues to stack more of the more sub-exposures that don't have that trail in it because the satellite's long gone, it will fade that out. So that's kind of how the stacking software works, and so that's what I use here is called SharpCap. And it's kind of magic, actually. It's pretty cool the way it works with what you can do with a modern CMOS camera, and software these days is truly astounding. What astronomers from 100 years ago wouldn't give to have that kind of thing. What us amateur astronomers can do now is typically far superior to what the best professional astronomers could do on the best equipment a century ago, probably even 40 or 50 years ago. But I just think it's a lot of fun, so that's why I do it. Let me unpin this so it gets out of the view. But yeah, this is a pretty neat little galaxy. So this is NGC 3726. Let's see what Wikipedia has to say about that. NGC 3726. Is a spiral galaxy located in Ursa Major. It's approximately 45 million light years away, which given its apparent dimensions means that it is about 85,000 light years across, as compared to our Milky Way, which is approximately 100,000 or a little over 100,000 light years across. So it's only a little bit smaller than our Milky Way. But it's a pretty nice spiral. You can definitely see the spiral arms in here. Oh, and I need to, speaking of seeing details, I need to set my enhancements here. And you may be able to hear in my microphone, you probably can, that got a little intermittent breezes here tonight, and also perhaps some clouds floating around as well. After I sent out my announcement this morning to do the live stream tonight, when I sent it out, the forecast looked really good for tonight, and by late this afternoon it had significantly changed. So the breezes shouldn't be too much of a problem. They'll be intermittent here or there. You'll probably hear it in my microphone. But supposedly we have a bank of clouds moving in from the west too. So we'll have to play that by ear. If we have to end early because we get clouded out, so be it. But so far, so good. I'm not seeing any clouds yet, so we'll just have to see how it goes. So this is about 45 million light years away, which means we're seeing this. We're seeing the light from this 45 million years ago. So this is how this galaxy looked 45 million years ago. How it looks today, we have no idea. We'll have to wait 45 million years to see, or figure out some way to get there so that we can see it. Oh, and I know what I also need to do. Let's turn on some of the background music too. Doink. Yeah. And always let me know in the chat, guys, if the sound levels are kind of off. I kind of have to guess sometimes as to what to set the sound levels at for the background music versus my mic. So let me know if anything needs to be tweaked on there. Hey Ollie, good to see you. I was wondering, with me having such a late start this evening, if you were going to get on from Germany and have a chance to say hey, and I'm glad to see you here, and happy Easter to you as well. Yeah, it's 7 a.m. your time there, so actually a decent time. Okay. It's so NGC 3726 is a spiral galaxy with a small bar seen with medium inclination. And I apologize for the yawns. Like I just said, it's a 10 p.m. start time here, so, and I was up early today and had a few hours worth of hiking in, and, and I tried to get a nap this afternoon but couldn't fall asleep, so hopefully I'm not going to be too tired and I'll be good for a couple of hours, but we'll see how it goes. So I apologize ahead of time for any of the yawning you're going to hear. The bar, so it has a small bar in it, so just a small bar, I guess, probably in the vertical direction there. Let's see if we can zoom in a little bit. See if we can see anything a little bit better. Yeah, so we've got a bit of a small bar there. And the bar is 1.38 arc seconds across, and it ends at an inner ring with 1.5 arc seconds diameter. The bluest regions of star formation are located at the ring. So this ring in here, I'm assuming, is what they're talking about. This is where most of the star formation is occurring in this particular galaxy. Make sure we got, probably get that down a little bit. So, but there's just a little, the central core is just misshapen a bit, and so there is a little bit of a bar in there. Hi Jeff, I guess Jeff and Jerry. Oh, I was just with you guys over on Gary's live stream. I hope things went better for him after I left. Yeah, he had seemed to have quite a rough start tonight. So welcome over here to the peaceful side of the world. Just the other side of California, actually, but I have a little bit more luck, I guess, getting things set up. Gary sometimes has problems with things over there and has lots of equipment to juggle and 2 people to kind of deal with the logistics around. So, but he pulls it off. He keeps his chin up and just keeps going. So it's really cool that he does that stuff. He actually, interestingly enough, Gary kind of inspired me to get started in doing what I'm doing this stuff too, and so it's nice to see that he is still sticking with it. Well, maybe you need to get out there, Jeff. Hey Frank, welcome over to the eastern side of California from San Diego there, where you guys were just spending the last couple hours with Gary and Dave. Welcome over to the Death Valley side. So we're just on We're just on NGC 3726 right now. We're continuing to work our way across. It's a nice little small barred spiral galaxy. And we've spent about 10 minutes on that, which means it's time to move on, because we got a bunch to do, and who knows how many nights we'll have to do it. All weather dependent, as always. So, alright, so there's 3726. Let's move on to the next deal. First, we got to make sure we add it to our list, so we know we don't accidentally do it again. Okay, good. Now, this one looks like it's a fairly good one. So yeah, 3938 will be the next one. Yep, right there. I can see a fuzzball right in there. Okay, so good. So let's just... Unlike Gary, who was having trouble with the latest version of the SharpCap Pro beta, and because he had to go back to the regular release version, he lost his ability to use his sequencers, his sequence scripts, which... I can relate to the problems that he would have on that, because now I've gotten so used to using these sequence scripts that if I had to go back to manual, there's no way I could do them all. I would remember all the steps to do. But anyway, he's continued to be a trooper and pull it off. So... But he seemed to indicate that there were some sort of resource allocation problems with the latest beta version of SharpCap, and I'm using that version right now with no problems, so I'm not sure what issues he was running into there, but anyway, it seems to work okay for me, at least so far, knock on wood. Yeah, there we go. This is kind of an interesting one. Huh. That's a pretty one. Very circular. Very circular. Which means we're probably looking at it pretty much straight on. Which is pretty cool. Let's see what we got. Okay, 3938. Let's see what Wikipedia has to say about 3938. NGC 3938. An unbarred spiral. So, the last one had a small little bar in it. This one has a no bar. Discovered in 1788 by William Herschel, is one of the brightest spiral galaxies in the Ursa Major South galaxy group, and it's about 67,000 light years in diameter. So this one is a bit smaller. The last one was 85,000. This is about 67,000. It's about 43 million light years away from Earth, so that's why this one's a little bit smaller. It's about the same distance as the one we just saw, but it's just a bit smaller. About 20,000 light years smaller, about 25% or so smaller than the last one. It's classified as type SC under the Hubble sequence, loosely wound spiral galaxy with a smaller and dimmer bulge. The spiral arms of the galaxy contain many areas of ionized atomic hydrogen gas, more so toward the center. In 2005, a supernova was discovered in it, and in 2017 also a supernova. Cool. Okay. Hey Joy, good to see you. You are up late. I did not expect to see you on, but it's really nice to say hi to you. Glad you could make it. Although you must be about ready for bed, I think you're at least one, if not two time zones ahead of me. I think you're 2 time zones ahead of me, so it's like midnight there, isn't it? But this is a pretty cool little variant. Now I didn't notice what does Wikipedia say declination. No, right center declination, magnitude, type, apparent size. Let's see if Stellarium says parallactic angle. I don't think that's what I'm looking for. Orientation angle, 28 degrees. 28 degrees, really? Oh, that's surprising. Huh, okay, well, I thought we were looking at it. It's so perfectly circular that I thought we were looking at it straight on. Apparently, we're not. Apparently, we are looking at it at a bit of an angle anyway, about 28 to almost 30 degrees, they're saying. That's kind of surprising. Huh. It's 11:20. Okay, you're only 1 hour ahead of me. All right. Still, I'm very surprised to see you, so that's totally cool. So we're totally international tonight, because Ollie is on from Germany, and Joy is now here from Costa Rica. So, holy moly, I've gone international. You guys have both been on my streams, I guess, before, but not together. I've never had two different countries represented at the same time. And for Ollie, it's 7:20 a.m. on Easter Sunday. So, and happy Easter to all of you who pay attention to such things. That's a pretty galaxy. If I can zoom in and get a little more on it. You zoom in, you get more detail, but you also magnify the graininess, so you gotta kind of take the good with the bad on that one. Let's see if we can bring this over just a hair. Looks pretty good. Yeah, the International Mic Show, yes. And actually, I was on TV today. I was interviewed yesterday by one of the local TV stations about my my live streams and my EAA setup and things like that, and we taped it yesterday. It was about a 12 or 13 minute segment, and it aired in the Las Vegas and Pahrump, Nevada area. It aired today, this afternoon, and it also will be rebroadcast tomorrow afternoon as well. So it was kind of fun doing that. I've never been interviewed for a TV show before, so you know, this EAA stuff really can take you places, I guess. I know, I just have fun doing it, so I think if you love what you do, they say you never work a day in your life, but I think also your enthusiasm can be contagious. And most people like being around that stuff. And I have a neighbor dog who just wandered into the yard. Hi, Oscar. He's a friendly one, though. Oh, good night, Joy. Thanks for stopping by. It was nice to see you, even if just briefly. Nice to have all the international aspect going on here. But it was fun doing the TV interview, and it's just fun talking about this stuff. You know, it's when you get to talk about something you love doing, it's a pretty cool thing. I think what I if I can remember, I'll try and put the link to the segment that I did in the description of this live stream when it turns into a video later. I'll try and put the link to the interview, because they broadcast it on TV, but it's also just up on YouTube. So it's just something you can watch on YouTube too. So if anybody wants to see what I look like in the daylight, you can check that out. So I'll try and remember to get that done sometime tomorrow, because it'll be too late tonight when I get done. And in fact, I've also got an early morning hike tomorrow where I'll be gone most of the day, so I'm going to have to sleep fast tonight. I have neighbor doggies walking through my yard. Alright, so NGC 3938. There it is, 10 minutes in all its beautiful glory. It's a pretty one. Almost a little pinwheel-ish. Like the micro pinwheel galaxy. Fun. Okay. Alright. So, next target. I did not switch my view. Cool. Alright. Let's add that one. Highlight it. And move to the next, which is going to be NGC 4013. Alright, we're working our way down. Perfect. Okay, good. It doesn't look like we have much of a picture in Stellarium of that one. But it should be... I think it's in here. I think there's a bit of a fuzzball there. We've been on good enough that I'm not going to worry about it. I think it's going to be pretty much dead center. We're making such small jumps between objects right now that it's pretty unlikely the mount is going to be off at all. Your dog always gets dangerously close to my trapeze. Yeah, well, that's the beauty of me having my cinder block pier. It's pretty hard to knock over. With my my cinder block pier here, it's I should probably, well, I don't know if you guys can see that low on here, but actually what I can do is this. Then you definitely can. These are all glued together with construction adhesive, so they're all one block. They are not glued to the pad, so if I ever need to, I can move it just with a two-wheel dolly, but these are all glued together, so no dog is going to move that around unless it's a very strong dog. Well, you had the right idea, Ollie. It's a pretty heavily put together thing, and beautifully weatherproof and waterproof, and can just sit outside forever and will never go bad. So I like it. I really just wanted to have something. The key for me was to just have something that could stay set up outside all the time, so that I can leave the wedge and the pier out, permanently polar aligned, so that all I need to do when I come out is just do a regular AltAz alignment, and I'm ready, up and going with a full polar alignment as well. And that was the key for me. And I got that idea from somebody on Cloudy Nights who said they were doing that, and I'm like, oh, that's a brilliant idea. Just leave the wedge and the pier out always set up. They're weatherproof, waterproof. You know, I'll throw a bag or a bucket over the top of the wedge if bad weather comes. But it's great to be able to leave that part set out permanently polar aligned, and then it's a relatively simple alignment and setup to put the rest together to get it ready for the evening. So it definitely makes setup a lot easier. Okay, computer needs food. I can do that. Boink. There you go. Alright, well, let's see what do we got here. This is 4013. Let's see what we can see about 4013. NGC 4013. U. Let's see. It's an edge-on barred spiral, about 55 million light years away. So a little bit further away than the ones we've been looking at so far, and it's absolutely an edge-on. So you can actually see as we're bringing more subs in, you can see the dark dust lane going right through the middle of it here, right through the bright bulge of the central core. I wonder how they know it's a barred spiral when they're looking at it from the edge like this. The disk of NGC 4013 shows a distinct peanut-shaped bulge in long exposure photographs that N-body computer simulations suggest is consistent with a stellar bar. Okay, well there it is. The next sentence after I asked the question answered it. To be seen perpendicular to the line of sight. Right, okay. So, you're thinking this peanut-shaped bulge, because it's peanut-shaped, suggests that it's a bar. A recent deep color image of NGC 4013 revealed a looping tidal stream of stars extending over 80,000 light years from the galactic center. This structure is thought to be the remnants of a smaller galaxy that was torn apart by tidal forces as it collided with 4013. Huh. Cool. But yeah, you can definitely see a dark dust lane through it. In fact, I might be able to if I can darken it down just a little bit, give it a little more, it might help. Look and see how well, yeah, see for you guys, yeah, I'm going to try darkening it down just a little bit. That I think will help you guys see a little better. Hopefully it will allow you to see the dark dust lane a little bit better. Of course, I've got to wait about 30 seconds after I make my changes to see them show up on my second computer that's monitoring the stream. Yeah, but that does help. That does help quite a bit. Okay, let's get rid of you. Doink. But yeah, they're saying there's that peanut shape, that oval or rectangular rounded peanut shape, rounded rectangular peanut shape is, they're saying is suggestive of a stellar bar in so the core of the galaxy is actually a bar. No problems with dogs for the CPC 800 tripod. Yeah, the CPC tripods are pretty beefy. I think those are 2-inch tripods, aren't they? That's pretty good. The CPC is basically Celestron's biggest, most accurate, most robust AltAz mount. To get any better than that, you have to go to a GEM type mount. So they have come with pretty beefy tripods. Huh. I wonder if you guys can see right down here. There's a nice fuzzy spot there that is not a star. Clearly a fuzzy bit here that looks like a another galaxy. Oftentimes in this whole region in here, there are just so many galaxies. I mean, many of these fuzzy spots in here are probably galaxies. This one definitely is, where it's got a clear oval shape. Yeah, some of these fainter spots are just so faint it's hard to tell. But oftentimes in most of these images, yeah, there's a faint fuzzy here. Fuzzy's definitely one up here. Very rich star fields in this whole region. Well, I can see there are some wispy clouds floating around, but they're mostly sticking to the east of us. So far, they're avoiding us, so hopefully that trend will continue. But if we do get some, I am seeing a little bit more graininess in the sky background than normal. So the transparency is definitely lower tonight than it was last night, but as long as we can avoid outright clouds, we should be okay. But there are definitely some clouds around right now, especially in the eastern sky. Hopefully they're going the other way. Good water. Ooh, I hit 60 subscribers today. Cool. Don't know if that's anything particularly remarkable, but it's good for me. This is a pretty cool, it almost reminds me of the Hamburger Galaxy. This is a much smaller, probably more distant version of that, but still pretty cool though. Alright, there's 10 minutes on that baby. That's good. Alright, I'll add you to the list. Highlight. And go to the next, which I think is 4051. No image in Stellarium again. Yeah, I needed to do this first, huh? Boink. Yeah, I think that's probably it right there. Chances are it is. Yeah, I love this sequencer. I love this sequencer. It definitely makes life a lot easier when you have to do a whole bunch of steps repeatedly. 4051. And it's so easy to forget to do a step. 4051. And then when you forget to do it, you get a crazy result and you don't know why. Because you missed one step out of, you know, several settings that you need to set and reset every time you do this. So it's the sequencer is definitely a very cool thing. Really enjoy it, and I felt for Gary tonight when he lost the use of his because he had to revert to the regular release version. But any event, NGC 4051 is an intermediate spiral galaxy in the constellation of Ursa Major, discovered by John Herschel in 1788. Let's zoom in a little bit here. Interesting looking deal there. Okay. 4051 contains a supermassive black hole with a mass of 1.73 million capital M. I wonder if that means solar masses. Don't really know. My light shroud is trying to blow away there. This galaxy was studied by the Multicolor Active Galactic Nuclei Monitoring 2-meter telescope. Several supernovae have been discovered. 1983, 2010, and 2003. The galaxy is a Seyfert galaxy that emits bright X-rays. However, in early 1998, the X-ray emissions ceased. As observed in the Beppo-Sachs satellite, X-ray emission had risen back to normal by August of 1988. So for several months in 1988, the X-ray emission stopped and slowly resumed, I guess. That's interesting. Wonder what caused that. Okay. This is doing pretty good. Pop a little more. You can clearly see some pockets in here. Some bright pockets, which tend to indicate some sort of high energy event is going on. Maybe lots of stellar formation or some such in these pockets here. Interesting galaxy though. Kind of weirdly shaped. Got this big lobe, big wispy lobe that's coming off here, and not much of one down here. There may be something there, but helio-radial velocity of 700 kilometers per second. Helio-radial. Wow. What does that even mean? Helio-radial velocity. Yeah, I see that in Wikipedia too. Helio-radial velocity. The radial velocity of an object with respect to a given point is the rate of change of the distance between the object and the point. Whoa, I don't know, the radial velocity, is the rate of change of the distance between the object and the point. That is, the radial velocity is the component of the Earth's, of the object's velocity that points in the direction of the radius connecting the point and the object. In astronomy, the point is usually taken. Okay, so radial velocity, I understand what radial velocity is. What is helio-radial velocity? What does the helio bit add to it? Huh. It's a pretty cool, interesting looking one though. Kind of different. It is definitely an interesting looking one, I agree, Ollie. A little bit peculiar. In fact, I wonder if it has a PGC number. Yes, it does. 38068. Peculiar galaxy. Interesting. Yeah, that's pretty good. It's only 8 minutes, but I'm not sure that we're going to get a whole lot more out of that one. Cool. Alright. Let's see what we've got next. Add it. Highlight it. Moving on. Let's see, what do we have? We got a bunch of them down there. Okay. Let's do this here. Ooh, mag 14 and 15. 3 and 2. You know what? I'm going to skip that one. That one's very small. So we'll just breeze right by that one. Speaking of breezes. Yeah, this one's pretty small too. Well, let's check it out and see if it's too small. If it's too small, we'll just move on. But this guy's looking kind of little. Yeah, in fact, I don't even see him in this. So, but that's okay. Let's pull a second, first 60-second exposure and see if it's worth sticking around for. Do you have a list or what about NGC 4112? Should be a group of 3 galaxies. 4111. Basically, the way I'm doing this is I'm just using Stellarium, and we're just gonna work our way across this whole field of dense field of galaxies between Ursa Major and Virgo and into Leo as well, and we're gonna do all those. probably spending the next couple of months just whatever sessions I can, just working our way through these little galaxies. Yeah, that's a little guy. Just a little sliver of a guy. I don't think we're going to spend any time on that one, because he's just so little. There's not a whole lot to see anyway. So we're just gonna blaze right on by. Say we did it. Move on. 'Cause we got lots of them that are in here, so we don't need to be messing around with anything. 4 and 1. It's kind of small again. 5 and 3. Yeah, that's a good one. 5 and 3. 5 arc seconds, or excuse me, 5 arc minutes and 3 arc minutes. That should be pretty good. Although again, I don't see it in the view, but I'm sure it's there. Alright, and so we've settled on 4242. So let's see. Where is 41? Okay, so you asked about 4111. Let me see. NGC. Oh. 40. Huh, interesting. It's not even listed in here. Why? Mag 10, Mag 10. Oh, because it's really tiny. So basically, I have it filtered out because it's really, really tiny, and so that tends to not be something that I do. But well, we'll take a look at it. We'll take a look at it right after this one. Oh, there's an interesting one. This one might be worth a couple of minutes. Looks like maybe it was sort of a barred thing going on. Sort of a bar in there and then a cloud. Almost a barred elliptical or something. 4242. Let's see what NGC 4242 does. NGC 4242. Like, let's see what you have to say. A spiral galaxy in Canis Venatici. The galaxy is about 18 million light years away. So this one is actually much closer than what we've been looking at so far. We've been in the 40 and 50 million. This one's only less than 20. It was discovered in 1788 by William Herschel. Very faint, considerably large, irregular, round, very gradually brighter in the middle, resolvable. By John Lewis Emile Dreyer, the compiler of the New General Catalog. Its galaxy morphological type means that it is an intermediate spiral galaxy with loosely wound spiral arms and is generally irregular in appearance. It was photographed by Hubble in 2017. The image shows an asymmetric center and a small galactic bar. It has a relatively low surface brightness and rate of star formation. It may be a satellite galaxy of M106 and is a member of the Canis 2 group. So it's a member of the M106 because what we're coming down to here is M106, which is kind of the big bright special one in this area. So we'll do that, not necessarily last, but we'll do that in just a bit. Histogram may be off. Yes, it is. is looking a little bit clipped. Yeah, that should be looking a little bit better. Yeah, we'll go take a look at it, Ollie, next. We'll go take a look at it. Like I said, the reason it isn't showing up in Stellarium is because its size. It's extremely small in size, and so I basically have my my filters set for DSOs. So the angular size, if it's below 3 or above 600 arc minutes, it doesn't show up, because that tends to be just so small it's not interesting to my scope. So that's why it's not coming up for me. Now you're saying it's a group of three galaxies, then we'll take a look at it. They may be really small, but if there's 3 of them, that could be interesting. Bit of a breeze puffing up. I'm sure you guys can hear it in the microphone. So far the clouds are mostly staying away, although something just blew off my table, so I'm gonna go fetch it. Okay. Yeah, definitely an interesting bar here. Oh, definitely have some wind picking up here in the last couple of minutes. Not really supposed to have much in the way of a breeze tonight, and it's been really calm so far. So, a little surprised we're getting a good breeze now, but we are definitely getting a good breeze now. So we may actually end up dropping subs if it buffets the scope enough. This number may go up to the point where it's a little too high. Well, it went down. Okay. Let's take a look at the individual sub that came in. Yeah, seems pretty round. Okay. As long as the stars stay pretty round, that works. I do have a pretty stout setup, so wind shouldn't be too much of a factor as long as it stays modest. Yeah, it's pretty solid for the most part. If we start getting double-digit breezes with 60-second exposures unguided, it probably will be too much for it, but so far so good. Like I said, we were supposed to have a little bit of a breeze tonight, but it's been, for the first hour or so, it's been really calm. Now all of a sudden the breeze has definitely started to kick up. So we'll have to see what happens here. The clouds continue to remain east of us, but supposedly there's a wall of them moving in, so we'll have to see how it goes. Oh, that's pretty good. Okay. Let's go up and do 4111. Doink. And it looks like, yeah, this PGC that I passed up is, I guess we're gonna get to do it after all, because it's gonna show up as presumably one of the 3 galaxies that are in here. Yeah, there's definitely one there. Alright. Let's see what we can see. Alright, well, let's see what we can pick up here. I can see on the level meter how the wind is affecting my microphone. You guys are probably hearing quite a bit of it. Alright, let's see what we got here. It's a couple seconds away. Boom. Okay, yeah, we've got 3. Oh gosh, at least 3 of this 4. So we got this one, and this one, and this one, and then there's one here, and there's another one here. Definitely down here there's one. Huh. Fuzzball up here as well. That's cool. Interesting little collection here. Yeah, there's definitely 4 or 5 right in this view here. 1, 2, 3, 4, 5. Fuzzy one down here. Yep. Very cool. Thanks for the suggestion, Ollie. That's a good one. Nice little group. S-shaped, huh? Jeff says there's an S-shaped one on the right. I assume he means this. There might be a slight curvature in that one. Is that the one you mean, Jeff, right there? I'm assuming it is. Oh, is Germany going to have some clear weather tonight? In April? Wow. Lucky night. Cool. Well, clear is good. Yes, cross fingers, knock on wood, all that kind of stuff. That's pretty cool. I guess I will mark this one as. I'll just add this to the. That's the one that shows up for me, so we'll just add it as seen and done. But that's pretty cool. $38,356. I'm assuming that is this one. Assuming right below this star that is it. In fact, what I could probably do if I turn off my filters, see all the other ones. Yeah, quite a few more in here. Now the problem is with this, scope is basically upside down. There are quite a few in here, you can see. But when I turn my filters on, they all disappear because they're too 4170. Nope, not yet. Not yet, I haven't. Well, this was a cool suggestion. Thanks, Ollie, for it. It's a nice little group. Let's see what's next. Got that one, got that one. I think what we're doing is we're just going to head down. Did I do this one before? This one I passed up because it was pretty small. It's about the same. Surface brightness of 14. also pretty small, but it's a bit brighter, so we'll try doing that one. No image. But it's close to 106. So you know what, actually, what we're going to do? I'm actually going to line on that star and see if we can't get them. Looks like we got another one here. See if we can't just get them all in one shot here. So there's 106 there. And if I do a flip and invert, well, I'm not sure. Let's try raising it up a little bit, just in case. Move it off just a little bit, not much, just a tweak. Well, let's see what we can get from here. If I've done my homework right here, let's try going up a little higher. All right. Let's see what that... If we need to move it one more time, we can. But I think we can knock both of these targets out in one swell foop here. That's the theory, anyway. Let's see what N106. 106. Doink. SER 106. Intermediate spiral. Canis Venatici. It was discovered by Pierre Marchand. 1781. It's about 22 to 25 million light years away. It's an active nucleus classified as a type 2 Seyfert, and the presence of a central supermassive black hole. Oh, okay, so see, we almost had it. I think this is probably... No, oh no, oh my goodness. Haha, we got a bonus. We got this in here. We've got 4220. So there's 4220 up there, because there's 106, and there's its companion galaxy right here. So there's 106 and its companion. And then there's 4220 right there. And then this one down here is going to be 4217. So we got all four galaxies in one shot here. Wow, 4217 is nice. It's got a nice dark dust lane in it. Okay, so we got at least 4 galaxies in the view here, although these two look like they're galaxies as well. This one looks like it probably is as well. It's a little bit too oval, a little bit too oblong. Well, that's pretty cool. Got a little lucky with this one. Let me get this histogram dialed in a little more sensibly here, give us a little bit better contrast. But yeah, these are, this is pretty nice. Six has definitely got some nice wispy stuff going on. But there's quite a few galaxies in this image. just got lucky to catch those two outliers together. That's fun. Yeah, my FOV with this is, I think, 1¼ degrees wide by 85 hundredths of a degree tall. I think it says on here. Yeah, 1¼ wide. Oh yeah, I was going to say 49, that's only 50, no, it's 49 minutes, so it's 50 minutes. Yeah, so it's 1¼ degrees wide by about 85.85 degrees tall. So it's, you know, plus or minus a degree, depending on which direction. So, depending on which way the scope is rotated, which right now in the northern sky is almost upside down. But this stuff is so high in the sky right now that it's I'm almost pointed at zenith at the moment, which is good because you get a lot of contrast that way. And the breeze thankfully has calmed a little bit. Definitely seeing some thin wispy clouds floating around. But so far they're staying mostly to the north and east of us, but they are around. And I am getting more, like I said earlier, I am getting more background noise, so the transparency is not as low. The transparency is lower tonight than last night. Last night it was definitely clearer. We're moving into a it was in the 90s today, so we're definitely into a bit of a warm spot and getting into a bit of a monsoonal flow pattern here, where we're going to get more clouds and stuff starting tomorrow, and so that's why normally, like I said in my announcement, I don't normally like doing two live streams in a row, 2 nights in a row. I think it gives everyone live stream fatigue, both me and you guys, if they're getting it done, doing it too much. So maybe more so me than you. But because the rest of the week is going to just be wispy clouds flying around day and night for at least the next 4 or 5 days, I figured I'd take advantage of the clear sky while it's here, even if it did mean doing a couple nights in a row. And tonight being a late start. Hey, thanks Jeff, thanks for coming by. Good to see you, and see you next time. Yeah, 480 APO reduced with the 178. Yeah. Yeah, you would, if you reduce the 480 down to 400 or whatever, that might give you roughly the same. See, the 178, I think, the 178 I think was about half the size. So I'm running about just a titch over 600 millimeters of focal length. Not reduced, just full on 610 or whatever millimeters of focal length. And the 183, like I said, gets me about 1¼ wide by 0.85 tall. And I think the 178 was right about, yeah, it was 0.47 degrees. tall. Is that right? Tall. I think that's right. 0.47 degrees tall, because I had to put that setting in ASTAP to get the plate solving to work. And this one is 0.85 tall, so it's right about, the sensor's right about half the size on the 178 of the 183. And I really liked my 178. It was good, but I wanted cooling. As the weather gets warm out here, and we go well over 40 degrees C. You know, we hit 50 degrees C sometimes in our hottest days. And on, you know, in our warmest summer nights, it won't drop below 100 degrees Fahrenheit, or it won't drop much below 40 degrees C until about midnight. So, you know, when I'm out here observing on summer nights, it's over 40 C, or 40 C or better. And so I really wanted to have some cooling. The 178 is a great camera, but it is noisy. It definitely has hot pixels, and the hotter it gets, the worse it gets. So what I really wanted to get was a 178 cooled, but they don't make those, and they haven't made them for quite a while. So the 183 was the next step up, and it was, you know, a lot more money, but it's worth it. The bigger field of view is just nice to have. I mean, the ability to do, you know, all this image here with all these galaxies in one shot. That's pretty cool. In fact, I can probably expand this out a little so you guys can see it a little better. That's pretty cool to be able to do that. So it's, you know, I got the cooling, and I got the bigger field of view just in a 183. No, Ollie, we hit 50 C in the daytime. Our daytime highs will be 50 C here on our hottest days, which is about 120 or so degrees Fahrenheit. On our hottest summer days, we'll hit 50 C in the daytime. And on those days, it sometimes won't drop much below 40 C until after midnight. So here it won't drop below 100 degrees Fahrenheit until midnight on those hottest of days. So, you know, when I'm out observing and it's still 40 plus C at, you know, 9, 10, 11 o'clock at night, it's nice to have the cooling on those on those, you know, the 178s and the 183s. Keep that amp glow down, keep the hot pixels down as much as you can. The 533 is really nice because it doesn't have any amp glow, but it definitely has hot pixels. So it's still a bit of a noisy camera, even though it doesn't have any amp glow. So it's nice having the cooling when you live in a really warm part of the world like I do. Well, that's pretty cool. There's 11 minutes. I think those came out nice. That was a nice score. Just got lucky with that frame. Okay. Moving on. That might be our most spectacular shot of the night. And we're going to add you, and we're going to add you, and we also got you. So all three of you guys, and we got you too, but you don't. Oh, you do. Cool. All right. Yeah. Got all of you. Got all of you. All right. Good. That was a good score. Okay. 41-44. This will be a small little guy again. Oh, I know why. Everything's looking very odd. Oops, no. Fine. Oh dear, I just hit the wrong buttons. I just hit the wrong hotkey and got myself completely discombobulated. Okay. Good. So we've got all those done. That's very cool. Let's try Caldwell 21 here. Oh, the box galaxy. Ollie, wasn't this the one you were just talking about? The box? Hey, Terry. Well, glad to see that you showed up. How's things in Muncie? I know it's pretty late there right now, I can tell you that much. Muncie, Indiana. Okay, so we got, let's try centering that up just a little bit more in the view here. Yeah, that's pretty good. Raise it just a titch. Yeah, that's about right. And I'll just recenter that. Like, yeah, okay, well, it's a little bit of a peculiar, but let's see what it looks like here. Start image. Okay, so this is the box galaxy 4449. Thanks, Terry. Really appreciate the compliment. I certainly have fun doing them. Sometimes I'm just rambling like an idiot, but I have fun, so. Okay, NGC 4449. Let's see what we got here. NGC 1239. And we go there. Is an irregular Magellanic type galaxy in Canis Venatici. It's located about 12 million light years away. Okay, so it's almost one of our local group. It's not very far away, only 12 million. It's part of the M94 group, or Canis Venatici 1 group, that is relatively close to the local group hosting our Milky Way. Yeah, it's only 12 million light years away. That's not too far. Well, it's an interesting one, that's for sure. Box galaxy, huh? Okay. Back the stretch off a little bit until we get some more data and see what we can see here. It's similar in nature to the Milky Way's satellite galaxy, the Large Magellanic Cloud, though is not as bright nor as large. NGC 4449 has a general bar shape also characteristic of the Large Magellanic Cloud, with scattered young blue star clusters. Unlike the Large Magellanic Cloud, however, the 4449 is considered a starburst galaxy due to its high rate of star formation, twice that of the Large Magellanic Cloud, and includes several massive and young star clusters, one of them in the galaxy's center. Photos of the galaxy show the pinkish glow of atomic hydrogen gas, the telltale tracer of massive star-forming regions. Its 4449 is surrounded by a large envelope of neutral hydrogen that extends over an area of 75 arc minutes. 14 times larger than the optical diameter of the galaxy. It's surrounded by a large envelope of neutral hydrogen that's 14 times larger than the galaxy itself. Okay. This envelope shows distortions and irregularities likely caused by interactions with nearby galaxies. Huh, interesting. Okay. So definitely a bit of a bar shape there. Oh, 2:30, and you had some great skies. So hopefully, Terry, that means you were out under them, enjoying them, and just didn't quite have enough before going to bed, so needed to get on here. I'm curious, Terry, as somebody from Muncie, Indiana, how did you hear about my live stream? That would be interesting to know. Oh, that's right, yes, 4170 was your box. Well, where is NGC 4170? Just 4449. NGC 4170. Oh yeah, so it's one of the ones we're going to get to, Ollie. Maybe not tonight, but it's one of the ones definitely in our path. So we will we'll definitely get there. It's in Coma Berenices, which is where we're headed. It's right in our path toward Virgo. So we will get there. We will get there. Just maybe not tonight. Again, the breeze is puffing around a little bit, but the clouds are staying at bay so far. So that's cool. Although I'm probably not going to be going a whole lot longer. I had a long hike today, and I have another early morning and long hike tomorrow that I'm doing with friends. So do want to get a little bit of sleep tonight. So I'll probably try going for about another half hour or so. Try to get another 2 or 3 objects in here before calling it. Honestly, it's not wowing me a whole lot. It's a pretty irregular kind of thing. See if our histogram adjustment, it's pretty good. The core is just completely blown out. Yeah, well, the nice thing, Ollie, is now that the time changes happened, things work in your favor, because now I'm only able to start, typically 8:30, 9 o'clock is as early as I can start now. Tonight was a bit of a late start because I wanted to wait until after Gary's live stream was done, and he finished. Well, he was supposed to finish at 10, but he ended up having technical problems, and so he and Dave ran a bit late, I think, with his. Actually, a number of the guys from there came over here. Jeff was over there. Frank was over there. So they can probably tell you. I don't know if he ran late or not, but so tonight I scheduled it later than normal just because of in deference to Gary's live stream that he was doing as well. So, but now that the time zone changes happen and the sun is going to be setting later and later and later, I'll be starting later and later and later. By June, I probably won't be able to start much before 10 on any given night, 9:30 or 10 o'clock, because the sun isn't setting till later 8:30. So hopefully you'll be able to see more of them now. So Terry says, stumbled on it searching the internet, been watching your videos last 3 days. I intend to share with our club. Oh, cool. You found me searching the internet, huh? Wow. That's pretty cool. Things are going to start happening for me now when internet searches start showing my stuff. I think I'm about done with this one. I don't think we're going to see a whole lot more. It's kind of an oddball. I don't think we're going to see a whole lot more than what we saw there, so we're going to move on to the next one. Let's go ahead and add you. Boink, boink, boink. And who's next? Oh, well, we've got something up here. That's kind of off the beaten path a little bit. Well, it's actually a fairly decent size. Oh, and the silver needle. Okay, good. Well, I think we're going to end with, I think we're going to do these three and we're going to call it. So let's head up and do 4145, and then we'll do the needle, and then we'll do M94, and that'll probably be tonight. Don't have a picture. Oh, here's something. What the heck is that? What is that? Huh, why does that not show up in my size 2? Oh, because it's just a little too small. Okay, well then, good. Then here's what we're going to do. We're going to center on that star there and do both of them. Because why not? I got a 1-inch sensor. I can do more than one galaxy. Now the question is, can I see them? Let's recenter. Let's flip and invert. And see if I can figure out who's who in the zoo here. Not really. So I think I'm just going to pull. Well, you know what? Let's just try doing a longer exposure. Okay, there's one. There's another. Okay, so there's that, and these two stars are here. So this should be just over here. So this actually should work. Okay, this should work. If what I'm seeing is correct, I think that should work. So let's give this a shot, and we should be able to get both of these together. It should look like this. In theory. Let's see how we did. Okay, I had the orientation wrong, but we got them both anyway. Okay, so there, that is clearly this one. This up here must be that one. Yep, must be. NGC 4145. Yeah, 4x3. Yeah, that's it. Okay. So we got them. Was not the orientation that I expected, but we did get them both. They're both there. So, cool. Alright. Well, we'll catch some subs here before we go trying to stretch things more aggressively. Get a little bit more data. builds in, I'm going to go refill my water bottle, get another layer on. Be right back. With the stretch, that might be a little much. Maybe not. Some nice ones there, though. This one, NGC 4145. Oh no, this was actually the one that's more interesting to me. 4151. Let's see, this one down here, 4151. NGC 4151. Intermediate spiral Seyfert galaxy with weak inner ring structure, located about 50 million light years from Earth. The galaxy was first mentioned by William Herschel in 1787. It was one of the 2 Seyfert galaxies described in the paper, which defines the term. It's one of the nearest galaxies to Earth to contain an actively growing supermassive black hole. It was speculated that the nucleus may host a binary black hole with about 40 million and about 10 million solar masses respectively. Wow. Orbiting with a 15.8-year period. This is, however, still a matter of active debate. Some astronomers nickname it the Eye of Sauron for its appearance. Sauron. So they think it's a binary supermassive black holes, with the largest one containing about 40 million solar masses. Jeez. 40 million times the mass of our sun. That's a big number. Huh. Interesting. Very interesting. We'll knock these 2 out. That's pretty cool. Boom. And boom. Very nice. Just about to come to our 10 minutes of data on these. There's 10 minutes. This is actually a pretty nice little spiral up here. Nice little arms with pockets of gas of star formation. It's a pretty cool one too. Alright. Moving on. Next Target. Let's see, I got it. Or I'll confuse myself. Okay, so we were going C26. The Silver Needle. U is next. Silver Needle Galaxy. I can't do both of those. Oh boy, no I can't. I can't quite get... Oh boy, it's close, but no. I can't get the 2 of those together. Yeah, there it is right there. Okay. Silver Needle. Go. $42.28 looks interesting. But I think we'll just do the Silver Needle, and then we'll do M94, and that'll be tonight. That'll be about all I can do tonight. Oh yeah, it seems to me I have imaged this before. It's 4244. NGC 4244. Also known as Cosmo 26, it is an edge-on loose spiral galaxy. It's part of the M94 group. A galaxy group relatively close to the local group. And it's very close to our local group of galaxies. In the skies located near the yellow naked eye star Beta Canem Venaticorum, but also near the barred spiral galaxy NGC 4151. Yeah, we know that. And irregular galaxy 4214. Yep, we knew that too. With an apparent V-band magnitude of 10.18, 4244 lies approximately approximately 14 million light-years away. A nuclear star cluster and halo is located near the center of this galaxy. Yeah, it's definitely a nice looking one. Definitely got some wispy parts and pretty bright part too. And we'll have to see how it comes in here. Don't see much of a dust lane on the edge of it though. But it is pretty. Silver needle. Yes, you definitely can hear the wind when it hits this microphone here. Luckily it's calmed down again a little bit, but yeah, it's definitely had some puffs. But so far the clouds and the wind are mostly staying away, and the cloud bank that was moving, it looked like it was moving in from the west, so far is staying off, so that's pretty cool. No, I didn't know you were working on a Galaxy Hunter scope. So, are you posting about it on Cloudy Nights? Or where is the information about this? Or can you tell me about it? Or what's it gonna be? Oh, 8-inch f5 with a parallactic fork. Okay. Is this going to be a visual scope or an imager or what? With f5 you can really kind of go either way. Okay. Yeah, definitely post it. I mean, you can post it as you go along too. But if you want to wait till you're done, that's fine. Alright, coming up on our 10th minute here. So it's for EAA. Okay. Why not make it an F4 then? Unless you already have the mirror and are kind of committed to an F5 mirror. But if you're going to stick with something that's for imaging, why not make it fast? Okay, well there is the Silver Needle. Silver Needle Galaxy. That's a nice one. That's a good size one. That is a good one. Add, highlight, done. Now we're just going to do M94. That will be it. Now the Croc's Eye. I have imaged this one a couple times. Oh yeah, needed to do this first. You can tell I'm getting tired. Boink, there it is, dead center. Okay, go. Go, go, go. Yeah, okay, so you already have the mirror. Basically, you're dedicated to the F5 because you've already got the optics already in place. Yeah. No, newts are great. Newts are great. I'm definitely as an imager, I really like having newts. They're bang for the buck compared to refractors is just way higher. Refractors are very nice. I'm not dissing refractors, but obviously per inch of aperture, newts are way cheaper. And depending on the type of work you do, if you're just sticking to DSOs, newts are, I think the best thing you can get. The faint fuzzy stuff. Yeah, there's that Croc's Eye. I think it's some of the best stuff you can get for doing imaging of DSO stuff. That might have cut it a little too much. But yeah, definitely. I like newts. For DSOs, I think newts are the best. I think newts are the best. If you're doing planetary work, if you're doing doubles, double stars, splitting doubles, if you're doing anything that requires really high resolution, refractors absolutely. No question. When you need to go high mag and have really good resolution on whatever you're looking at, refractors absolutely. But when you're just shooting DSOs like I like doing, I think the newt is the way to go. I just like them. I just like them. Croc's eye. Let's see. If it's a Messier 94. Messier 94. It's a spiral galaxy discovered by Pierre Marchand in 1781 and cataloged by Charles Messier 2 days later. Although some references describe M94 as a barred spiral, the bar structure appears to be more oval-shaped. The galaxy has 2 ring structures. Yep. It's classified as having a low ionization nuclear emission region nucleus. Liners, in general, are characterized by optical spectra that reveal ionized gas present. Blah blah blah. M94 has an inner ring with a diameter of 70 arcseconds, given its distance of about 5,400 light years, and an outer ring with a diameter of 600 arcseconds, about 45,000 light years. What? M94 has an inner ring with a diameter of 70 arcseconds, given its distance about 5,400 light years, and an outer ring with a diameter of 600 arcseconds, about 45,000 light years. Okay, so it's less than half the size of the Milky Way. I think what they're saying, the inner ring has a diameter of about 5,400 light years, and the outer ring has a diameter of about 45,000 light years, and the Milky Way is about 100,000 or so. These rings appear to form at resonance points in the disk of the galaxy. The inner ring is the site of strong star formation activity and is sometimes referred to as a starburst ring. The star formation is fueled by gas driven dynamically into the ring by the inner oval shape, bar-like structure. Cool. This is one of those objects that's kind of tough to image because the inner part is so bright compared to the wispy outer part that if you want the inner part to look good, you have to kind of back off on the stretch. Or then you start actually seeing a little bit of detail in the inner part. A little bit of a swirl in the inner part. If you can back off on the but then if you want to see the outer part, you have to really stretch the heck out of it, which then of course completely blows out the bright core. So kind of a tough thing to image. But this is why Charles Messier thought it was a comet, because the core is so bright. It's a really bright object. See, now I can actually see a couple of spiral arms here. One right there, another one right here. Blow it up a little bit. Yeah, so you can definitely see a strong thing there and a strong one there. You can see kind of the swirls headed out. Definitely a swirly bit in there. Definitely a swirly bit. I'll do one more minute, and that probably will be it for me. Add this. Twink. So we've got a good chunk done. Got all these done. And all these left to go. So we'll have a good couple, 3 months to get all that done, but it's be fun doing it. So I'm not sure when my next live stream will be. Like I said, the reason I did 2 in a row tonight is because this weekend is because it's the next few days are looking kind of crappy-ish. So not sure when I'll be back, but hopefully it won't be too long because we got a lot more galaxies to go. So anyway, I think I'm going to call it a night. Thank you everyone for being here, and hope to see you again next time. So thanks everybody, and I will see you later.